standard. Similarly, technical standards. Let's see what are these technical standards described like. Any technical standard should be describing the requirements for a product. For example, a car tire. If you say R17 or R19 or R16 car tire specification is standard, and that means it should specify all the parameters for that car tire size. Similarly, an electric plug, what should be the for a 110 volt supply or 220 volt supply, what should be the distance between live earth and ground, neutral. So these are also very, very important. Those are the requirements of a product which we fix it as a standard. Then we have processes, quality management, good agricultural practices. All these come under standards for processes. Then services, your travel and tourism. These are also come. There are several such kind of things. So you will have the standards which will describe your requirements, describe your process, describe your services, and how to test a particular property, test and measurement thing. You would have seen what are its color fastness and what is tensile strength, what are its physical properties which describe them. Then classification of systems, levels of security, level 1, level 2, level 3, and at each level what should be the performance, and then a dictionary of terms in terms of vocabulary, and then good practice. These are all the guidelines for installing something. What is the good practice for installing a particular device, a particular equipment. And for this, you have different standards. And if we see the benefits for micro, small, and medium-sized enterprises, the benefits of standardization definitely reduces the risk of mistakes, reduce the time, effort, and money to invest in their individual R&D, because they have already standardized protocols. They don't need to have their own R&D for fixing the design parameters. Help assessment of their processes, which they can always compare with the standard process. Provide a reliable benchmark against which performance can be judged and demonstrated. Okay, and help retain existing clients because they are following a particular standards. If a particular MSME is following particular standards, you would have seen any company, ISO 9001, ISO 14002, that kind of standards, your clients also can be attracted to you, because when the enterprise becomes accessible to potential customers requiring compliance with standards. This is very, very important. And this will also aid to maximizing compatibility with products or services offered by others. Right? There always has to be compatibility, because no big product is always designed and produced at one place. You will be outsourcing different subcomponents to different clients. And unless you have these standards, you cannot have that compatibility. And this will ensure the business meets regulatory obligations and provide information necessary for trading in new markets anywhere in the world, anywhere in the country. Once you are maintaining a product of that standard, you can always trade anywhere in the world. And that's the reason why these standards are a set of documents established by consensus based on the consolidated results of science, technologies, and experiences. Because the standards are always collected, and then formed, regulated by a group of experts, domain-specific experts, where they have understood, they have taken into consideration the science behind it, the technologies involved, and the experience over the years. Standards are commonly recognized rules and provisions. That's all. There is a misnomer that standards are all only a set of rules. They go all these things. Similar to that, they are just rules and provisions to follow. That's how they help us. They can include comprehensive technical specifications which describe the characteristics and requirements of products, procedures for product production, testing, and conformity assessment methods. So the application of standards provide better efficiency in the production of products, as we have just seen, improves quality of services all over the world, and contributes to meet the highest level of clients and consumers' expectations. This is exactly every product or every company desires, and which will increase the trust of society in standards. It is important to ensure the wider participation of interested groups in the development and discussion of standards. That's exactly what the international standard organizations take care. And the standards are developed, revised, amended, modified, or withdrawn from time to time, depending on the innovations in the science and technologies development. In tune with the market needs, and in response to society and market needs, the necessity of standards development is day to day increasing. Now let's see what is this standardization in a nutshell. Whatever we have discussed so far, we'll be just putting it in a sentence form. Standardization is nothing but successful products do more than simply solve a market problem, and you can trust what they will always be of a certain quality, be safe to use, and are readily available when you need them. Standardization is always making a product into a household name, a standard brand name. Okay, now you would have seen, Xerox, how it has become a household name. Otherwise, it's just a photocopying machine. But the Xerox company, they have monopolized the entire world, and it has become a product, a household name. That's the brand. Again, Google, the way they have democratized the information. You can say Google has become a part of the vocabulary. You can Google for that information. And that's how, that's what is standardization. The ability to scale while maintaining consistency. This is also very, very important. And then standardization sometimes is misunderstood by many as a simple checkbox for regulators. Is a way to ensure your product's consistency as you scale and grow into different markets. Because you are scaling up and growing into bigger markets and different markets, diversified markets is not all that easy without adhering to a particular or compliance to a particular standards with this global competitiveness. And this can help accelerate market entry while clearly communicating what your customers can expect from you. And then why this standardization? This standardization is very briefly, we'll just go through all these points. They increase the safety of products. They serve as a basis for improving the quality of products or services. They ensure that products are fit for their purpose and consistently perform in the way they were intended. They lead to better efficiency in the use of resources in the process of product production, support the legislation in the process of preparation and implementation of technical regulations, because if at all some states and countries have to prepare some legislation, they always have to take the basis of standardization. Only then they can frame the legislation. Otherwise, they have to put a lot of effort in again forming the committees and taking their reports, all such things. They also serve as a basis for establishing agreements concerning the technical requirements and provisions. This increase producers competitive edge definitely, and they also contribute to the removal of technical barriers to trade. Once you have a particular standard, trade can have barriers for this. And ultimately, it facilitates the maintenance of ecological global balance, very, very important part, and contribute to the protection of the planet. Now, for this reason, as we have just discussed, International Standards Organization, or it's actually called as International Organization for Standardization, although it's called as ISO, which is an independent, non-governmental international organization with a membership of around 165 national standard bodies. Through its members, it brings together experts to share knowledge and develop voluntary consensus based. This is important because there was no consensus or Kyoto Protocol has failed. We will see it in the end. Okay, and then market relevant international standards. These three are very important. You should have a voluntary, consensus based and market relevant international standards that support innovation and provide solutions to global challenges. That's the basic role of ISO. That's the reason why in London in 1946, 65 delegates from 25 countries met to discuss the future of international standardization. And it came to realization in 1947, ISO officially came into existence with 67 technical committees. You can know each committee is a group of experts focusing on a different specific subject. Now today, ISO is today has 23,429 international standards covering almost all aspects of technology and manufacturing. There are 165 member countries respecting. There is only one member for each country, and 792 technical committees and subcommittees to take care of standards development at regular intervals, keeping in the innovation in mind. And how this ISO is standardized, international, it's all in the name, because International Organization for Standardization would have different acronyms in different languages. In English, you would have called it as IOS. In French, you would have called it as OIN, in different other language. But the founders decided to give in a standard short name as ISO, which is derived from Greek isos, meaning equal, because equalization everywhere. And whatever the country, whatever the language, we are always ISO. That's how the ISO came into existence. Then the second very important standards commission was International Electrotechnical Commission, which is the world's leading organization that prepares and publishes international standards for all electrical, electronic, and related technologies. CE is different compared to this, because it's a compliance standards produced by this IEC. And close to 20,000 experts from industry, commerce, government, test and research labs, academia and consumer groups participate in IEC standardization work. Now, IEC Technical Committee prepares these international standards, which are essential tools in the fight against e-waste. This is a very, very primary priority for this IEC Technical Committee, while aiding manufacturers to meet legislative requirements on toxic substances control. Since its creation in 2004, the IEC TC has published a number of crucial international standards relating to the environment. It is preparing for a future where recycling in a circular economy could well become the norm, while recovering the rare earth metal, a process known as urban mining, may become widespread, because urban mining means the day and day how we are going to spreading. We are going on spreading the urbanization by removing the trees. ETech is another wonderful platform published by International Electrotechnical Commission covering the news on IEC standardization. Okay, and this ETech is a platform for regular updates and interviews which explore diverse areas, including major energy, major environmental susceptible technologies like power generation, transmission, distribution, renewable energy sources, energy storage, public and private transportation, information and communication technologies, smart grids, and smart cities. So this that's the reason why this IEC becomes a very important standards organization when it comes to protecting the planet. So before they can even think of recycling the various materials they use in their goods, suppliers need to know, because it is essential, and report the substances in their products so as to conform to various pieces of legislations that exist across the globe. For this, I've just only taken a few standards. IEC 62474 is a group of standards which establish the requirements for reporting the substances and materials included in electronic and electrical products. As you will see, e-waste is going to be the major hurdle, major problem in the years to come. And that's the reason why they have taken care of these standards to take care of these electrical and electronic products. Similarly, IEC 62321 family, which defines standardization methods for determining the levels of potentially toxic substances in electrical and electronic products by using various methods of measurement. This is how they have defined. And IEC 6243 is family of standards, provides guidelines for minimizing the adverse environmental impact of devices throughout their life cycle. If a particular device is there throughout their life cycle, how it is going to affect the environment. That's what this family of standards decide. So the publication defines environmentally conscious design for all electrical and electronic products. For instance, which materials are used, the quantity of energy consumed to make them, as well as their rate of recyclability. Because if you see the solar energy, we all talk about solar energy as a green energy. If you consider the amount of energy, primary energy that goes in making a silicon cell, in making a glass panel on it, in making an aluminum frame, in making steel frame, both in windmills, the amount of steel that is required to make the large or high windmill. If you take the primary energy into consideration, if you still think in terms of absolute energy, it's really a big question mark whether we are really or whether all these technologies are really energy efficient. Anyway, that's a different field of study altogether. That's exactly what is the quantity of primary energy used to make them also a very, very important factor in considering. That's exactly what these IEC standards define. Then the third one is basically the International Telecommunication Union, another standards basically for Agency for Information and Communication Technologies, ICTs. It was founded in 1825. In fact, this is one which started with Morse code, which became very popular in the early ages, early technologies, Industry 1.0, 1.4. It was founded in 1865 to facilitate the international connectivity in communication networks, allocate global radio spectrum and satellite orbits, develop the technical standards that ensure networks and technologies seamlessly interconnecting them, and strive to improve access to in ICTs to understand communities worldwide. Every time you make a phone call via mobile, access the internet or send an email, you are benefiting from the work of ITU. That's the standard set by internet. Then the fourth one is IEEE standards. IEEE has a set of standards for all the smart cities. Anyway, I'll not go through this. You have for smart grid, you have a set of standards. For intelligent transportation, you have set of IEEE standards. For e-health, you have a set of standards. For energy efficiency, you have set of IEEE standards. Internet of Things, you have to follow for architecture, precision timestamp, sensor networks, and all these things, you have a set of things. Then 5G communication, you have standards. Cyber security, for both encryption, physical security, intelligent electronic devices. And then for e-governance, you have IEEE standards. Smart homes, you have IEEE standards, and the learning technologies, you have IEEE. So all these, I expect you to please go through all these standards and try to understand how each standard is going, what are the rules and regulations in all these standards. So IEEE has come out with a wonderful standards because the future are all going to be the smart cities. And if we really follow all these standards, we will definitely be protecting the planet. Okay, so then in the end, let's see, there are also environmental standards, but still we call them differently as protocols, although they are the rules and regulations. An environmental protocol is a type of international law, an intergovernmental document intended as legally binding with a primary stated purpose of preventing or managing human impacts on natural resources. So that's how the Montreal Protocol came in 1989, which was supposed to serve up to 2005. And basically, the prime aim of the Montreal Protocol was to reduce the chlorofluorocarbons, right? Like CCl4 and R12, R22 refrigerants, which are depleting the ozone layer in the stratosphere. Okay, and the primary objective of the Montreal Protocol was to reduce these CFCs. And if you see the CFCs, we normally call them as greenhouse, powerful greenhouse gases. And all the chlorofluorocarbons, they're all used in refrigeration and air conditioning. And their use is going very rapidly, and their use actually depletes the ozone layer. And the Montreal Protocol gradually succeeded. They became successful in converting the use of CFCs, chlorofluorocarbons, into hydrofluorocarbons, which are much beneficial to the ozone layer. Okay, instead of beneficial, and not much detrimental to the ozone layer. So because of which, you would have seen why the Montreal Protocol necessitated was nearly 1.6 billion air conditioning units would have been installed worldwide by 2050, making the problem even worse. Luckily, sustainable and energy efficient alternatives are available, including natural refrigerants. Okay, and the Montreal Protocol was with an ambitious agreement to reduce hydrofluorocarbons. Because of this, 100 billion tons of carbon dioxide equivalent by 2050, and reducing 0.5 degrees centigrade of global warming by 2100. This was the target. And in that extent, Montreal Protocol considered to be the successful. We will see it in this. With Montreal Protocol, and we have the UV index. 11 and over are considered to be the more dangerous. With Montreal Protocol, that's where we have. And without Montreal Protocol, this is the projected UV index, where we would have gone around 25 of UV index. That's where the Montreal Protocol, and then it was followed by Kyoto Protocol somewhere in 1998 or 1978. It was again reviewed in 2005. So the main aim of Kyoto's protocol means again standards, was to reduction of 6 major greenhouse gases as defined by IPCC. IPCC was a intergovernmental panel on climatic change, constituted by the United Nations Council to control and monitor the 6 greenhouse gases, namely carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbon, and sulfur hexafluoride. So all these are basically emissions of either through refrigerants or through combustion processes. And Kyoto, before 1990, these were the status of all the major developed countries, and industrial countries were expected to cut the emissions to 5% below 1990 levels by 2008 to 2012, and it never happened. Okay, and it never happened because of the reason, because all these are powerful countries because of their standard of living, and it was very difficult for them to come to that 1990 level, because of which the Kyoto Protocol is considered to be a failure based on the report of the World Bank. You will see it here which came in 2012. This is a very simple bar graph where you will see on y-axis we have the ratio of carbon dioxide emissions to GDP of each thing. Then red thing is the year 2010, and blue is by the year 2035. This is 2010 and 2035. And the levels were before 450 ppm, before 1990. Then you have new policies in between, and then current policies. With the current policies existing, you will see here, and this remaining same as for the year 2010 as a base benchmark, you will see this ratio is continuously increasing. Okay, the carbon dioxide emission per GDP is continuously rising, and that is where we have to be prepared. We have to be conscious of protecting this environment while concentrating on growth and development to maintain our standard of living. So with this remarks, I think I have complied with the time given to me of 30 minutes. And anyway, the whole PPT will be available with the Institution of India organizers. I can, if there are any queries, I can take the questions. And I take this opportunity that again I have to thank all the organizers for making me to learn and relearn many of the concepts of standardization and global warming, and making me to collect all this information, to collate all this information, and facilitate you all in making literate of all such terminologies, technologies, and process and standards. Okay, so thank you very much. Thank you one and all for your